In this video, I'm going to be showing you the answers to the odd-numbered problems on this polarity practice. So the first one we have is H2O, water, where we'll have the oxygen and the two hydrogens. I'm just going to put the letters in them rather than coloring them. Okay, so as we look at this molecule, we should know that oxygen is much more electronegative than hydrogen, and since it's in this bent shape rather than this straight line shape, and you should have seen that from the simulation, the PhET, that this is a polar molecule where we have the partial negative on the oxygen side and the partial positive on the hydrogen side, because the oxygen is going to attract those electrons more strongly. Number 3, we have SO2. And we have a similar situation here where this is a bent-shaped molecule, so we have a top side and we have a bottom side that are different. So this does make this polar. Now in this case, oxygen is more electronegative than sulfur. So the oxygen side, sort of the bottom, is going to be the negative side, and the sulfur is going to be the positive side. Remember, the more electronegative side is going to be the negative side. H4. Okay. Next we have ClF3. So this one is kind of a T-shaped molecule. Cl, here's F, F, F. And so you might look at this and think, well, there's F's on every side, so that's symmetrical. But because it has this T shape, right, this side over here is different than this side over here. There's more fluorines on this side. There's a fluorine here, and there's not a fluorine there. If I turn it, that's different, right? So this one is going to be polar. And since fluorine is more electronegative than chlorine, the fluorine is going to be the negative side. You could think of it as like these two fluorines are pulling in these directions, and that's kind of an even tug-of-war. But this fluorine is pulling down, and there's nothing up here pulling back up except for the chlorine. So we're going to have our partial negative here on the bottom by this fluorine, and our partial positive on the top, on the side where there is no fluorine over there. The final molecule is CH4, which is methane. So we have a carbon in the middle, and then we have 4 hydrogens surrounding it. Now this one is kind of three-dimensional, but you could picture it as sort of this hydrogen maybe is coming out of the page, and this hydrogen maybe is going back into the page. So for this one, we have hydrogens on every side. No matter how we turn this molecule around, it's still going to look the same from every side. It doesn't have two different sides. So this is going to be a non-polar molecule. Yes, the carbon is more electronegative than the hydrogen, but if it's being pulled evenly on every side, you don't get more electrons on one side or another side, so that is non-polar. So I don't need to mark a negative or a positive on that one. All right, so please check your answers and let me know if you have questions.